Oh.
Well, what? Excuse
Alright.
Excuse me.
What's up, everybody? Are you ready? No, I'm not. Guess what comes after 7? 20. Lots of things do. But in particular, 11 does.
Well, technically, none of what we said was wrong. Technically, I was right. You could say he was right, and the other was right. As long as
Alright, so
I get it. You're funny. You're funny. Never do that again.
alright, listen. So this requires some justification because normally we don't do things out of order. That's just not in our not what we do. So the reason that we normally wait to actually it's always been true that polar and complex this unit we're about to start on polar functions and complex numbers fits very nicely with what we've just done. But we've always kind of like waited till the end to do it, just so that to like make you do trigonometry one more time before you like get kicked out of the door on pre-calculus. So we've always intentionally done that. But part of the reason we're doing this now is because it fits even more nicely after having added some of that matrix stuff. So there's in fact some added lessons within this unit too, which will be like some worksheets as well. The homework 9 and 10, which is like still left up in the air. I think it's going to be 2 homeworks. I don't know. It's like nebulous extra portion of this unit. Okay. So anyway, homework 1 will be what's assigned tonight, but not talked about or checked until Monday, I guess, or Tuesday. Anyway, so whatever. It's not a very super hard, challenging homework though, which is good because you also have like an IA to work on between now and Monday. So. The draft is due on Monday, right? Everyone has that on their calendar? Right. Yeah. So Monday, wait, hold up. Sit down and hold a second. Homework, yeah.
So you said that the homework would be checked until Tuesday, but are we going to be having homework the day after? So it'll be like 3 homework Tuesday or something?
No, it's just homework 1 plus your IA draft. It's due Monday, right? But the reason I say we're not going to check it or talk about it until Tuesday, homework 1, is because when we get together on Monday, we're going to do kind of like some peer meeting with peers about your IA and do some kind of debriefing about that and stuff like that. Hopefully you have something to show for it, so, you know, something to bring something to the table on Monday. Okay. That would help.
That's a wonderful
sure.
IA draft.
Did you have a question too, or did I answer it? The first question. Okay. 2 per se. Alright. Yes.
So you're trying to tell me that following with Unit 11 after Unit 7 isn't some part of an elaborate grand deal?
No, but I hear what you're saying. Alright.
I'm here all week.
What's up?
Get it? 7-11?
I think you should be like 50% of the way done or more on your entire project. So whether that indicates that you've typed a bunch up or whatever, I mean that might be something you've been doing. But the very form that like you're like well on your way with the bulk of like any data collection and analysis, or if you're doing research of some kind, that's like mostly done, like whatever. That you have like a very clear picture of what's happening and you're like on track. Okay. I mean that would be ideal, right? That would be ideal. I have a story to tell you, okay? There was a big mix-up in the box office. We were going to this little theater in downtown DC actually, back in, oh yeah, that's right, 2010. And they gave me at the will call, got the envelope, and my tickets were in there, supposedly my tickets, but this is what I got. Though in retrospect, I was thinking to myself, that's a show I think I want to see, you know? It's a little pricey, especially for a teacher, you know, but that's pretty good. I was like, I think I can go to that show. That was not the show, that was a mix-up, but I did give it back to them, but only after taking a picture on a white piece of paper in very even light, okay? Isn't that incredible, though, that that would have happened, that like, little mix-up? That's remarkable. That's one of the units I do in pre-calculus.
I mean, that background is perfect.
Yes, Johnny?
The real cost, is it 44, 49?
Oh, that's with tax. That's with tax. And the tax, you know what I mean. It's or no, what is this? Convenience charge charge. You know what I mean? You know how they do those
What's the
theaters.
175? Wait.
Enough questions. Okay. All right. Yeah.
Wouldn't it have been better to do it as like an airplane ticket to the North Pole?
Yeah, that would have been cool, but
Don't mind me.
next time maybe. You don't know what's in store. Okay. All right. Let's introduce you to a new world. Are you ready to enter in to the new world? Okay. There is another way that people sometimes keep track of coordinates and equations and things that happen in the coordinate plane, and sometimes they use this thing called polar coordinates. Okay, so let's introduce you to how we might keep track of these coordinates. This is called the polar grid. Sometimes we use these kind of like radial, it's kind of like radial graph paper almost. In fact, I think I have some of this over here if you want. And instead of the positive x-axis, sometimes we call that the polar axis. So you're still welcome to call it the x-axis, even in this new environment. That's fine. Ian, I'm giving you 4 today. This is number 3. Go.
If you end up with that having used twice the size, if you end up having it be bipolar.
That's funny. Okay. The pole is sometimes the other thing we call the origin. Though again, you can still call it the origin though, if you like. That's not a problem. It's just sometimes you call it the pole. And nothing else to say about that. By the way, these angles are all ones you should recognize, right?
Yeah.
Pi over 12 is maybe not one you normally mark on your graphs. It's just 15 degrees, but whatever. There's nothing special about the angles. So as we go out further, we're moving one more unit away from the pole, and then we have these angles to keep track of as well. So how might you name a point in polar coordinates? Well, let's put one on here and then ask you. I hope you realize that this is a good way to name a point. It gives very specific instructions to a particular point, doesn't it? If I give you r and theta, then that tells you exactly where the point is, doesn't it? What does r mean, do you think? It's a good name for it. What do you think it means? Yeah.
The distance, like the radius.
Yeah, the radius, the distance from the pole that we are, and theta, I think is fairly clear by our naming convention. Names are powerful, aren't they? Theta means the angle. Yeah, and we always name them in this order as like an ordered pair, just like we normally would and it's only clear because of the context that we mean r comma theta and not x comma y, because we write them both the same way. Okay, so what would you think that what would you name that point? For example, what would r be? Keep in mind that as we move away from the pole and cross one of these circles, we've moved 1 unit away more from the origin. So 1, 2, 3. What do you want to call it? What comma what? Yeah, 3 I think is r, and the angle would be 5 pi over 6. Great, that's a great way to name it. And again, it's only clear that we're even talking about polar coordinates because we happen to be in a context. So that's r comma theta. Okay. Okay. Now, an interesting thing though to mention that doesn't happen in x and y coordinates, in rectangular coordinates, is the fact that there are other ways to name a given point. So give another name for this point. For the same point, you could give other instructions on how to get to where we're going. Yeah.
3, 17,
Okay, absolutely. Give another one. 3, what does it say? Oh, in degrees. You can name it in degrees, true. What else? Yeah. Yeah, you guys were going for exotic things. Yeah, that's what I was thinking too. You could name it that. But there are, to be clear, just to emphasize what you said especially, right? There are an infinite number of ways to name that point. In fact, there's even more ways than you might have expected. We allow for negative r values in this new world also. And that makes sense. We just mean 3 units in the opposite direction of where we're pointed. Right? So how else, given that inspiration, how else did you name this point? If we're allowed to say -3 for r. Yeah. Yeah, so we could be pointing in the 11 pi over 6 direction and instruct someone to walk, if you're pointed in this direction and you're standing at the pole, point in the direction of 11 pi over 6 and walk backward 3 units. Doesn't that also give you instructions to get to the same place? Or we could maybe, here we got like positive, 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 negative, negative, positive. We could also do, we write one so that we got like -3 comma You can also call that negative pi over 6, right? So there are lots of ways, and actually this is only 4 of an infinite list of things that would work. So are you clear on how these work? I always kind of like to act these out. So the first one, if this is a positive x-axis, then the first one tells me to turn to 5 pi over 6 and walk 3 units. There I am, right? The second one tells me to turn negative 7 pi over 6, that's clockwise 7 pi over 6 units, and walk 3 units. Aha, look at that, I'm at the same place. The third one tells me to turn to 11 pi over 6 and walk backwards 3 units. Yeah, same place. And the last one tells me to turn pi over 6 clockwise and walk backwards 3 units. All of them get me to the exact same location though, right? Okay. Welcome to polar coordinates. Okay, can you name all the different coordinates you could give for this? No. That's a lie, yes you can. Okay.
Wait, but Mr. James, you said there are infinite, so you can't.
Yes, we're going to name them. Harness the power of math. You say that as if it's a bad thing.
Oh, 2 pi n.
Yeah, we can rope in the integers that are to be our servants in this matter. Oh, it's not that. Stop here. Appropriate use of the word. I'm ready when you are.
I'm not ready when you are.
So, yeah, I mean, what would you like to do in order to prove your point about 5 pi over 4? Let's start with the ones that are, we have 863, comma, what? Certainly 5 pi over 4 works. What else? Negative 3 pi over 4, yeah, right? And anything that's equal to 5 pi over 4 plus 2 pi n, right? So I think we've just picked up all of the angles, haven't we? Where n is some either positive or negative integer, right? Like for example, if n is negative 1, then we get the thing you just said, negative 3 pi over 4 here, don't we, for the angle? If n happens to be negative 1. Though I guess given the setup I gave you a second ago on the previous slide, I also said though that that the r value could be negative too, couldn't it? So let's name all of those too, and then I think we'll be done then. We'll have named every possible way someone could possibly name this point, right? So would that be negative 863, comma what? Anybody? What'd you say? Negative pi over 4, I have to think about this. I think negative, yeah, I think pi over 4 is what we want, right? Plus 2 pi n. Does that pick up, are these all the same instruction here? Getting to the same place? Think hard about this. Okay. It's just pi, it's just 180 degrees off, isn't it? These two things. Okay. Did we do it? Did we just name them all? I think someone doubted us that we could do it. But there it is, all of them, even though there are an infinite number of them, there they are. Okay. You name this coordinate in any way you like, and I will tell you where it is on the list I made, right? That's the point. Okay. Okay. This is a polar coordinate, that is r comma theta. Give the rectangular coordinates x comma y. Ready, go. Yeah, like x comma y. Yeah. Rectangular means x comma y. Our normal way of doing it. Give Have you figured out why this is a nice follow-on from last unit? I mean, really, what am I asking for here? I've given you kind of like, what do we call this in vector land? What do we call this? Yeah, I've kind of given you magnitude and direction, haven't I? And you're coming up with like component form. We're like putting a different gloss on it, but that's why I have every confidence that I can just throw this at you and go, right? Even though I've never talked to you about it. You have done this, actually. Figure it out. By the way, in about 5 minutes, we're playing a game. Get ready. Get ready to play a game.
find a difference.
I forget it.
Figure it out.
Oh wait, no, you multiply it.
Draw a picture. Draw a picture if you need to.
So since x is negative 1 over 5. X is negative 1/2, then y is radical 3 over 2. And then you multiply by 40 and you're done, right? Did you get that? Did you get that?
What quadrant is this in? You don't even know those things in the calculator.
I don't know what I did.
All right, who wants it? Franklin wants it. He does. He wants it. Go ahead. So explain. Listen.
I don't know.
All right, everybody simmer down. Okay,
So
Franklin,
the coordinate for 2 pi over 2
take it away.
is negative 1/2 then square root of 3 over 2.
Yeah.
Multiply the magnitude by half.
Oh yeah, so you're kind of thinking it's like 40 times the unit vector in the 2 pi over 3 direction, kind of, right? Yeah, I like that idea of it. And that's correct. Yeah, let's just go right for the x coordinate. What would it be if we're like, I saw you drawings of triangles and maybe drawing pictures. We're in the second quadrant. How do we get x? Let's start with x. 40 times something. What is it? Go back to vector land for a minute, right? How did we do this in vector land? Yeah. Which is in fact what Franklin said too. And 40 sine 2 pi over 3. Does this ring a bell? Am I right that this is not a foreign task? Okay. And each of these things is what Franklin said. 40 times negative 1/2. And over here 40 times root 3 over 2. So we get the rectangular coordinates. Is this what you got? I saw some people had this. Yeah? Is that in the second quadrant too? Yeah, I think we did a good job. Yay, okay. So I hesitate to give you this formula because you already know it, right? But yeah, if you want to convert things from polar form to rectangular form, see unit 7, right? It's just the same. There's nothing new under the sun. I gotta hurry because I gotta play this game. Yeah, you do. You're gonna love it. You're gonna love this game. No, it's not Stevie. That's good though, I like that. Alright, can you go the other way? This time you'll need a calculator. Remember, this is just like last unit too, right? Here's component form, give me magnitude and direction. That's all. Nothing new. Just the front.
The back is a little better.
Yeah.
I just feel like my dad
All right, so R is what? What's R? R is, how do we get R? R is the square root of something? Yeah, this is in quadrant 4. I just want to make sure I'm straight. So when in the end I get an angle, I better have it be a quadrant 4 angle, right? So what's our way in on this? You could use, I don't recommend using arc cosine, though you could just adjust afterward into quadrant 4, but arc cosine doesn't give you, anyway. What did you use? I don't know. Inverse sine? I might even use inverse tangent too, but an inverse sine is fine too. Anyway, that's not a nice number. What does it come out to be? Something negative, right? Negative 60.3. Can someone confirm degrees? Okay. So r and theta we've got, so we can just write this down here. R, comma, theta. I didn't say whether you wanted to do it in radians degrees, so do whatever you like. Stuff when people do it in radians. It's fine. Okay. So I put this up here again with hesitation, because it's stuff you already know, right? Like that, and this even comes with a footnote, right? But it's a footnote you thought about, right? In terms of getting the angle into the right quadrant, you know that this doesn't tell the whole story, right? Certainly true that the tangent of theta equals y over x, but it doesn't tell you immediately what theta is. Okay. So adjust for quadrants. Again, not a new discussion, an old one. Okay, we gotta play the game. Okay. You emotionally prepared? All right. All right, we are going to play a little game of Battleship, okay? Yeah, on polar coordinates, though, okay? All right, so I recommend, how about at your table, you should pick a partner. And face off. We'll do 2 on 2, okay? Maybe so like, I don't know, you guys versus you guys, right?
Partner.
Man, I wonder who
Alright, so maybe 4 of you face off here, 2 on 2. 2 of you come up and face off with me again, okay? Alright, let me tell you how this works before we do it, okay? Let me use this as our example, okay? So when you draw these coordinates, you're gonna place with your teammate, and the reason you have a teammate is so that like you can just check each other on your math and stuff like that. So you're gonna place with your team member the following 5 boats. This one here, it's a aircraft carrier, I think, right? Destroyer, 4 long, submarine. What? What's wrong? I think I gave you, like, tell them to pass them down. And then there's a 2 one, right? Everyone only needs 1 piece of paper, so pass those over. You should get, so I think I gave you 6. You need 1 more? Okay, I'll bring you 1, don't worry. So with your team member, agree on where you're going to place these ships on your grid. It's pretty clear if you're making like a 3 long ship, you could put it like right there, say, right? But you can also, takes a little bit of imagination, but you can also put them like this. 1, 2, 3, like say you have a 4 long boat. Okay, it's a curvy boat. Okay, the only thing we'll disallow is like they're all diagonal, but like a diagonal boat like this, okay? Okay? Do not do that, okay? Is that cool? So you hide your boats, and then, have you played this before? Make sure they can't see it. I love this technique right here, yeah? Feel free to move your desks however you like to make this happen. Place your boats, and then once you go, you fire away. They say hit or miss. And when you sink a ship, they say hit and sink. They say that, right? Okay? So then you know that you sink. When you...
So we're just trying mercy kill.
When you name...
I get it.
When you name a coordinate, you need to use
straight line or plus minus
plus minus.
center.
Minus plus right? So set up your grid, make sure the people you're facing off against can't see though, okay? So you guys are against that? Yeah? So make sure they can't see you. Yeah, sure, yeah, exactly. That way, you don't set up barriers. You're right, so when you name the point, use one of those for naming your actions, which it has to be. Well, no matter what, you're going to call it, okay? Because you can name it in any way. We're just forcing you to name it in that certain way. There's no limitation to what you can get, that's for sure. Who are you facing off against? Aren't you facing off against those guys? Wait, what? Well, whenever you're ready. Wait, they're preparing a grid. Yes, 2v2.
So close. Battleship, you're screwed.
Alright, whenever you're ready, start playing. Did you hear the extra snag? Did you hear the extra snag that you need to name your points alternately, like it says on the side on the left? You need to name them positive, whatever point you want, you should be able to name it in whatever way I specify, right? So plus plus or plus minus, something positive, comma something negative, r comma theta, right? Or negative, negative, whatever it says on the side, you have to guess in that way. Okay?
No, let's do this. Wait, do we have to write down what they need to do?
You don't have to.